think it's 69.
69, that's right.
Wait.
Now, alright folks, thank you for tuning into the 69 lecture of linear algebra. Now, as you know, today is an extremely important lecture. And why is that? Because today we're going to learn how to diagonalize a matrix. And now there's...
How do you diagonalize it?
That's a great question. Now there's many trillions of ways to diagonalize a matrix, but today we're going to look at perhaps the most important way, which is using eigenvectors, eigenvalues, and the determinant. So are we ready, folks?
Yes. Perhaps I'm a little bit more ready
I can see that
than the other people.
from the tone of your voice. Now, our do now is going to be a kind of a refresher into the eigenvectors and the eigenvalues, okay? So our do now is simple, okay? Oh, geez.
I think the other guy will struggle today. Not Mr. Rodriguez. Not Mr. Rodriguez.
Hey, you have to be nice to Americans too.
Excuse me. Which?
I thought Puerto Ricans were respectful,
What?
as respectful as they were smart.
Yeah.
Identify
You
the...
should be a little more humble,
Thank you.
not arrogant.
Okay, excuse me.
I'm not talking to you, although you are very arrogant.
Okay, so
I did.
I'm inventing notation on the go, so don't worry if you see something crazy. Okay, identify the
What is wrong with
eigenvectors
you?
of the following matrix. 3, 0. Well, as a tribute to our lesson number, I'll use 6, 0 and
09.
0, 9. Okay. Okay, so I'm going to invite both of my students to go ahead and come up to the board and identify the E sub V vector.
What is E sub B?
Eigenvector. So that's the notation I've created and I use.
Eigenvectors before eigenvalues?
Yes. One student is rubbing his eyes and
How
one
do you know
student
the
is staring at
eigenvector
the
if you
floor.
don't know the eigenvalue?
My friend, you seem to be deeply misguided, okay? The eigenvector, what is the definition of eigenvector?
There is an equation that is lambda.
Okay, well, basically the informal definition is a vector
Vector does not change
change its what?
when through transformation.
It doesn't change it.
It doesn't
Span.
change its span.
So if I take eigenvector and I take its span before a linear transformation, that's gonna be equal to its span after a linear transformation. See?
Yes.
Span before of the eigenvector.
What is span after?
Span after. Okay. So if you have a matrix that is made out of the unit basis vectors, then the eigenvectors are staring you at the face. Here's the eigenvector. Here's the eigenvector. Oh, sorry if my head is cut off. I do have a head, so. So.
Okay.
So it's the eigenvectors are right here, 6,
Yeah.
0, 0, 9. So unfortunately, you have both failed the assessment, and now we're gonna move on to the do now.
Yeah.
So you understand why the answer.
Unfortunately, what?
We have both failed the assessment.
I
that is
missed
the
that part.
We have both failed the assessment that is the do now.
He said it a little too fast.
Fancy word
No,
that you
well,
learned
let's try to
yesterday.
review.
Assessment! Assessment!
Yes, ma'am.
Assessment!
Okay.
So we were asked to identify the eigenvectors of this matrix.
Nobody
We-
can see what you're writing because half of it's good at the wall.
We know that the definition of an eigenvector is that it preserves the span before and after a linear transformation. So that means the eigenvectors of this matrix is simply the new I hat and the new j hat. Because remember, I hat before was simply what? 1, 0. Now it gets scaled up to 6, 0. So its span is the same. Okay, so this was I hat before. Same thing for j hat. J hat was 0, 1. Now it's span to 0, 9. 9 times bigger.
Okay.
So the span is the same. So that's why the eigenvectors are 6, 0, and 0, 9. So
What
you,
about like
so the final answer
what
is
about like 2, 0 and 0, 2?
These are the final answers.
Why did not the 2002? Could
Oh,
those be
that's a
eigenvectors?
good question. He asked a very good question. He said, why can't 20 and 02 be eigenvectors, right? That's because all eigenvectors have to be linearly independent. If I said that 20 is an eigenvector, that means 60 cannot be eigenvector. Because look, they're multiples of each other. They're not linearly independent. All eigenvectors have to be linearly independent. So maybe I should write that down. All eigenvectors must be
Linearly independent.
linearly independent.
Meaning that we have to do something with both an x and y component.
Yeah, okay. So now today during our lesson we're gonna find out how to diagonalize a matrix. Okay? So who's ready for that? Let me see a show of
Not
hands.
me.
Okay.
Do you understand this, new student? I should say something.
Okay. Okay, so our lesson today is very simple. Some may call it a joke, okay? So let's see. Let's take a look at our matrix. So diagonalize. We're not going to have enough space if I do that. So diagonalize. Oh. Okay. Let's see. And
Stop laughing, instructor.
sorry. Okay. So here's our matrix, and you will be asked to diagonalize it.
So
Okay.
first in order to get the eigenvalues, we have to make sure that upper triangle,
Do we?
upper right triangle, yes. Otherwise, then we can use the diagonal as the eigenvalues.
Okay. Well, maybe that's a different method, but I'm gonna use just find the eigenvectors first.
No eigenvalues.
Eigenvalue first.
So how are you gonna get the
So,
eigenvalues?
By
You get
using AP equals.
okay, can you
lambda v.
then do both methods?
Okay. So let's see.
Okay, do you know how to use the row echelon formula?
Of course.
Okay, so row echelon, then the C21 gonna become what?
Oh god. C21, that's gonna be 0.
0.
And yeah, that's the only thing that needs to be 0 here.
Yeah, can
Okay.
you do
But what
that?
about that 9?
Oh,
No, 9 doesn't have to be 0.
oh, we'll do it after we first do
Okay,
that.
sure.
Okay,
That
so
doesn't diagonalize the matrix.
No, it's fine.
students. Okay, so we're gonna obviously subtract the right hand side. Lambda v
So
equals
factor
0.
out V.
Factor out v, and what do we get?
A lambda.
No.
Identity vector. Identity matrix.
That's better. Yeah, identity matrix.
And then lambda.
Lambda equals
0. Okay.
Student, can you turn off the music, please? Hey,
I
don't play
can't turn
music.
it off.
Don't play music in my
It's
class.
on the
It's not
road.
my music.
It's on the road.
Oh, it's on the road.
We don't
appreciate
control
it.
the road. We are not traffic.
Okay.
Yeah. Not the police.
So now,
That's more.
I have to set the determinant of this equal to what?
0.
Okay, so let's do that.
How would you
So-
do that?
Well, this is pretty. This is a joke, right? Oh,
I'm
whoa.
used to
We
it.
just. Thank you for the.
Lost ones to it.
Okay,
Yay.
so what is our matrix A? Okay, let's stay focused. The determinant of this is 0. So what is my matrix A, folks? Oh, in fact, why don't I ask our student to come up here right now?
Yeah, right now.
I see that he's kind of, he thinks his job is over. So please,
No.
come up here right now
Why
and
did I say that?
go ahead and
Liar.
write the matrix A. First, check if the marker is edible.
Matrix A.
Please.
Matrix A is
I
3,
just
0,
put
0.
I just put the bars for you. You have to write it big.
3, 0, 0.
Okay.
3, 4, 9.
That's already wrong. It's minus 349. Let's stay focused.
0, 0, 3.
Okay. And minus what? Minus?
Minus I is going to be identity. So
Yeah, which is?
that really. Oh yeah.
Uh,
and that we need
lambda
Eigen-
0. Yeah, wow, these guys.
Wow.
Who told you? Nobody.
Oh, thank you for your input. Now please go back to
You
your seat.
deserve some, like, some punishment.
That was
Wait, I need some more. I need some more things.
okay. Go ahead and simplify that if you can. My friend, what is this? Is this a matrix or an AND? Expand, please.
Okay, -3. Okay, so -3, and then 4 minus lambda.
Excuse me. It's actually okay. Yes. Go ahead.
Trying to sabotage me. I see your little quirks. 0, 0, 3 minus.
Okay, so I'm gonna take it from here. So I'm now gonna ask our other student, Alex. We now have our. This is what? What matrix is this? This is
I don't
A
know.
minus lambda times identity. Now I'm gonna ask you to find the determinant of this. So
Okay,
thank you.
I know. Wait.
Whoa.
How do you
Yeah.
find the determinant of a 3 by 2?
Alex, any ideas?
Oh, multiply. I don't know. I have no idea.
So this is what I will write here. Okay. How do we find the determinant of a 3 by 3 matrix? Do you want to see?
Yes.
Yeah.
Okay, so this is what we do. Okay? This is what we're gonna do. Are you ready?
Yes.
Who's ready? I wanna see.
Oh my God, we said we are ready.
Okay. So here's what I'm gonna do. Stay very focused because this is incredibly difficult. So if you don't stay focused, it's gonna be very hard. Alex, can we focus?
Yeah.
Okay. So what are we gonna do?
Respect the Florida region students.
What we're gonna do is kind of make architecture. We're gonna make buildings.
What
Okay.
the-
So we're gonna kind of make this kind of building. That's a building.
That's a building?
Okay, so the determinant of this big matrix A minus lambda I is gonna first and foremost equal this 3 minus lambda. This is just a formula, so you can memorize it. I'm gonna prove it in a couple of hundred lectures later. So this is gonna be our scalar quantity 3 minus lambda, and that's gonna be multiplied by the determinant of this matrix. This kind of miniature matrix, 4 minus lambda and 9, 0, 3 minus lambda.
So this is 4 minus lambda.
But we're not done. That's just one part of the determinant. Now we need to take the next part of the determinant.
Oh, it's
Okay.
not easy to do other way. This is.
Oh, no. The greater the pain, the greater the suffering. So, what we're gonna do now is the next part. Okay?
The greater the pain, the greater the suffering. So you mean the greater the bread, the greater the suffering?
It can be said many ways. Okay, now let's see. Now I'm going to take my next scalar quantity. What's my next scalar quantity? Highlight it in blue. What is my scalar quantity? 0. See? And we're going to multiply that by the determinant of this blue miniature matrix. -3, 4 minus lambda, 0, 0. But we're not done. And there's a final third step. Right? It should be negative. Audience, I want you to tell me what my last step should be. If you're dumbfounded, you can.
I don't know.
We simply take
I
this.
know.
Okay.
I was about to do this. And then we do,
Oh, sorry, this should actually have been a. Excuse me.
do,
Student, head back to your seat.
sorry, no student interaction. Rude.
Okay? So, since our scalar quantity is going to be 0 for both of those, this is going to cancel out, and actually it doesn't matter what's inside. So we're going to be left with what? Okay, what's, Alex? So, what is this? 3 minus alpha, lambda, times, what is the determinant of this?
4 minus lambda.
4 minus
times
lambda
3 minus lambda minus 0.
minus 0, and all of that is equal to 0 because we know that the determinant of everything is 0. Now we can find the eigenvalues, which are what?
So we just find it.
Well, yeah, or you can notice that it's just 3 and 4. If you plug it in, it gives you 0, right?
Oh yeah.
Okay, so we found the eigenvalues. Now we just have to find the eigenvectors. That's the easy
Oh, now
part.
easy part.
Now the easy part.
Can you also do this other way, the triangleize?
Yeah.
Let's see how long that takes.
probably like.
So we have to get rid of -3.
Yeah.
So let's multiply the row number 1.
So okay.
Oh no, we don't have to multiply.
No.
Just add row number 1 and 2.
Yeah. So we just have to do 3. Oh, we have to find the eigenvectors now.
No. We can find the first. Let's find the eigenvalue by changing the right triangle.
We found the eigen.
No, we want to find the other way.
Oh, new way. Okay.
New way.
So what do you want to do?
3 0 0. We want to get rid of -3 and write 0 there.
Oh, you do you
I
want to?
also want to get rid of the 9.
Do you
No,
want
we don't have to.
Then that doesn't make it that perfect diagonal.
Do you want the row echelon form?
I want to make the diagonal form.
Okay, sure. So let's see, 3
0
0
0.
0. Let's add them. So I
Zero.
We
get
only
4
want
9.
the 3, the 4, and the 3.
Okay.
So now the eigenvalue are 3 4 3.
But
Yeah.
really?
Yeah, that's the diagonals of the eigenvalues. That's it. It takes 1 second. 3 4 3. Yeah, that's it.
Kind of.
Yeah.
This is not a diagonal though.
The diagonal. Take the diagonal. What is the diagonals? 3
But
4 3.
it's not a diagonal matrix.
No, it's not the diagonal matrix. It's the triangular, upper triangular.
Okay. Oh.
So in upper triangular, the diagonals are the eigenvalues.
Right.
Okay.
I knew that.
Okay.
Of course. You lie about what you know.
Okay.
Okay, now we have to find the eigenvectors.
Find the eigenvectors. Put the 3 in the lambda.
Okay.
So now write the he wrote it lambda 0 0 0 lambda 0.
Yeah.
Oh no. Use that matrix. Use that matrix.
Yeah, I know. So 3
3
minus
0 0.
3. Okay, 0 0. Right?
Yeah.
Minus 3, 4 minus 3.
Or minus 3.
Since our other student is in such pain and agony, why doesn't he come up here and go ahead and do the math?
No thank you.
No, please, come up here. X, Y, Z, and this has to equal a 0 vector, right?
Yeah.
So student, please come up here and do the math.
No thank you.
Excuse me.
No.
Okay.
This won't be it. Well, can you take this place? Can you take my place? This
So
won't
4
be it.
minus
Yeah.
3, 0, right? Okay, so let's simplify. 3 minus 3 is? 3 minus 3 is?
That's I need calculator.
Okay.
0 0 0 0.
0. 4 minus 3 gives me 1. And 3 minus 3 again gives me 0. Now I need to multiply this and this, right? This matrix with this vector. So let's go ahead and do that. X times 0, -3 naught, plus y times not 1 naught.
Why do you
Plus.
call 0 not now? Why being so fancy? This isn't physics.
Not 9 naught
I'm supposed
is.
to be the one who's
equal
fancy
to
and using
not
all
now.
the decimals.
Now we just have to multiply these out, okay? So Alex, take a look over here.
Yeah.
So I just multiplied these matrices in the hope to find the eigenvectors. So let's multiply these out. What do I get?
Oh, I get x 0 0 0 0.
Okay, that's easy.
That's easy.
Then?
-3x
Minus 3x
plus 3y
plus just y
y plus 9z
plus 9z equals y.
0.
Okay, now we just have to solve for it. So let's see if x is, give me some pairs of numbers that is gonna make this one. Integers only.
1 2 3.
1 2 3 doesn't work. It doesn't give me 0. Do you want me to give you
1
one?
zero.
No, hold on.
0 1 1 0
Three.
1 1
X is 3.
0 1 2.
You're just guessing. Look here.
Can you do it?
Yeah. So for example, let's say y is 0, right?
Right.
So then if this is 1, this has to be
3.
minus 3, right?
No, plus 3.
Right? So, oh yes. Plus 3, that's right. So this is minus 9, this is 9, this is 0, gives me 0. Is there another possibility, combination?
But that's minus 9. Oh yeah, plus 9.
Is there another combination I can use?
Yeah.
What is it?
602.
602 is unfortunately not. Yeah, 602 is a multiple of this. It's not linearly independent with it. Remember, all eigenvectors have to be linearly independent. So 602 does not qualify.
Minus 3 minus 0 minus 1.
Oh, say it again.
Minus 3 minus 0 minus 1.
Minus 0. minus 1. So let's see if that works. So this gives me 9, that gives me minus 9, but does anyone see a problem with this?
What?
Again, this is not linearly independent with this. See?
Oh.
Yeah. So you have
It's a
to.
multiple. It's a negative multiple. Though.
Yeah, you have to be careful.
Oh,
with
it's on the same line.
But there is one you can do by just making this one 0. Make this one 0. Let z be 0. So then if this is 1, this can just be 3. Now they're not only linearly independent, but they're distinct eigenvectors. Now all we have to do is find the last one. We already found 2 eigenvectors. We need the last eigenvector. Give me a raise of hands. Who can tell me the next step for finding the next eigenvectors?
Okay.
Okay.
Wait.
Okay, so we have 3 minus 1. 3 minus? What's my eigenvalue? 4.
Wait.
4 minus 4. 3 minus 4.
I
So
jumped
3
out at 903, but that's
So what's-
I did wasn't.
What is 3 minus 4?
Minus 1.
Minus 1. What is 4 minus 4?
0.
And 3 minus 4?
Minus 1.
Good. And now all I have to do is just multiply these out. So I'll have minus 1 here. I'll have 0 all the way through right here. And I'll have 9, negative 1 here. So, give me the system of equations for this. Who wants to multiply this out? Please tell me what this is multiply out to.
Minus x.
Minus x plus what?
0 plus 0
Equals?
equals 0.
Okay, next line.
X is 0.
Okay, next line, please.
Minus 3 x equals to 0.
No, minus 3x plus 0y plus 9z
9z.
equals 0. Next line.
Wait, that means z is also 0.
No, they don't all have to be true. It can be this or the last line, which is what? Minus z equals? Now, either x is equal to 0 and z is equal to 0, or what?
Minus 3x plus 9z equals.
No, you have to give me the vector that satisfies this. What is it?
0.
Well, let's try minus 1. If I try minus 1, is that going to work? No. So I have to
0,
try...
1, 0?
No, come on. You have to do just 3 and 1. 3, 0, 1.
Ow.
Does that make sense?
Yeah.
How does that satisfy minus x is 0? We
Hmm?
want x to be 0.
What do you want?
Minus x is 0. How does that satisfy minus x is 0?
Oh, well then why don't you just make this another vector like 0, 0, 9. What about that? So I have 0 of the x's, that will give me 0. 0 of the z's, that will give me 0. And 9 of the y. Y is already 0. So that will give me 0, right? So if I put these 3 eigenvectors in my...
But doesn't 0, 1, 0 also work? That's the linear...
Remember, that's linearly dependent with this.
No. We can use 0, 1, 0.
No. We actually
0, 1,
can't.
0. Wait,
Not in
why
this
not?
case. We'll take a look in the next lecture, okay? So, what are my 3 eigenvectors? Can the class tell me? What are my 3 eigenvectors? I wrote them already. What are my 3 eigenvectors?
3,
3,
0,
4.
1, 1, 3, 0, 0, 9, 0.
So I think
Here, and
3
here.
and 4.
3, 0, 1,
Eigenvector, yeah.
1, 3, 0,
Yeah.
0, 9, 0.
0 and 0.
All I have to do to find the diagonal is just drop them in. See how easy it is? 3, 0, 1,
Yeah, so we have to find the
1, 3,
diagonalize,
0.
yeah.
0, 9, 0. And that's it.
Subscribe to Bari Science Lab to fall in love with math and science, especially programming.